بسم الله الرحمن الرحيم.
Dear students, today we will go through lecture 10 of organic based industries. The topic of today's lecture is polyester production and application. Polyester is a category of polymers that contain the ester functional group in their main chain. As a specific material, it most commonly refers to a type called polyethylene terephthalate. Polyester is a synthetic fabric that is usually derived from petroleum. This fabric is one of the world's most popular textiles, and it is used in thousands of different consumer and industrial applications. Chemically, polyester is a polymer primarily composed of compounds within the ester functional group. Most synthetic and some plant-based polyester fibers are made from ethylene, which is a constituent of petroleum that can also be derived from other sources. While some forms of polyester are biodegradable, most of them are not, and polyester production and use contribute to pollution around the world. Key concepts include polyester structure, history about polyester manufacturing, different forms of polyester, manufacturing process of polyester fiber, chemistry involved in polyester synthesis. Polyester is a synthetic resin in which polymer units are linked by ester groups through nucleophilic acyl substitution type of reaction. This reaction is also known as Fischer esterification. Esters are obtained by refluxing the parent carboxylic acid with appropriate alcohol in the presence of an acid catalyst. The equilibrium can be driven to completion by using an excess of either alcohol or carboxylic acid, or by removing water as it forms. Alcohol reactivity order decreases from primary to tertiary, where tertiary alcohol is least reactive due to steric effects. Esters can also be made from other carboxylic acid derivatives, especially acyl halides and anhydrides, by reacting them with appropriate alcohols in the presence of a weak base. Ester formation reaction is a 6-step reaction. Step 1 is an acid-base reaction. Protonation of carbonyl makes it more electrophilic. Step 2. The alcohol oxygen functions as nucleophile and attacks electrophilic carbon in carbonyl. Step 3 is an acid-base reaction which involves deprotonation of alcoholic oxygen. Step 4 is also an acid-base reaction which makes OH leave by converting it into a good leaving group through protonation. Step 5 uses the electrons of an adjacent oxygen to help pushing out leaving group, a water molecule. Step 6 is again an acid-base reaction which deprotonates the oxonium ion and reveal carbonyl in ester product. Polyester began as a group of polymers in W.H. Carruthers' laboratory. Carruthers was working for DuPont at that time when he discovered that alcohol and carboxylic acids could be successfully combined to form fibers. Polyester was put on the back burner, however, once Carruthers discovered nylon. A group of British scientists took up Carruthers' work in 1939. In 1941, they created the first polyester fiber called terylene. In 1946, DuPont bought all legal rights from the British and came up with another polyester fiber which they named Dacron. Polyester was first introduced to American public in 1951. It was advertised as a miracle fiber that could be worn for 68 days straight without ironing and still look presentable. In 1958, another polyester fiber called Codal was developed by Eastman Chemical Products. The polyester market kept expanding since it was such an inexpensive and durable fiber. Many small textile mills emerged all over the country, many located in old gas stations to produce cheap polyester apparel items. Polyester experienced a constant growth until 1970s when sale drastically declined due to negative public image that emerged in late 60s as a result of infamous polyester double knit fabric. Today, polyester is still widely regarded as a cheap, uncomfortable fiber, but even now this image is slowly beginning to change with emergence of polyester luxury fabrics such as polyester microfiber. On the basis of morphology, polyester exists in four different forms: filament, staple, tow, fiber fill. These different forms of polyester are used in different places. Filament form. In filament form, each individual strand of polyester fiber is continuous in length. It is used in production of smooth surfaced fabrics. In staple form, filaments are cut to short and predetermined lengths. In this form, polyester is easier to blend with other fibers. Polyester tow is like polyester filament, but in polyester tow, the filaments are loosely arranged together. It is a form in which continuous filaments are drawn loosely together. Fiber fill is the voluminous form used in manufacturing of quilts, pillows, and outwears. Polyester fiber fill is also used for stuffing soft objects such as stuffed animals. It is also applied in audio speakers for its acoustic properties. It is commonly sold under the trade name polyfill or untrademark as polyfill. Polyester fiber is manufactured from long chain polymers composed of an ester of a dihydric alcohol and terphthalic acid. The most widely used polyester fiber is made from linear polymer polyethylene terephthalate, and this polyester class is generally referred as PET. High strength, high modulus, low shrinkage, heat set stability, light fastness, and chemical resistance account for the great versatility of PET. Process flow chart of synthetic fiber production is shown in diagram. The process of creating polyester fiber begins with raw material preparation done by reacting ethylene glycol with dimethyl terephthalate at high heat. This reaction results in a monomer. In second step, the prepared monomer is reacted with dimethyl terephthalate to create a polymer. Then the molten polyester polymer is drawn through extruder and stretched into long strips. In the next step, these strips are then textured by cooling, drying and breaking apart into small pieces. The resulting chips are then melted again to create a honey-like substance. Depending on whether filaments, staple, tow or fiber fill is desired, the polyester chips are reacted with various chemicals to achieve the correct end result. This process is intermingling. Then in heat setting, the honey-like substance prepared in previous step is extruded through a spinneret to create fibers. In most applications, polyester fibers are spun into yarn before they are dyed or subjected to other post-production processes. Raw material. Polyester is a chemical term which can be broken into poly means many and ester, a basic organic chemical compound. The principal ingredients used in manufacture of polyester include ethylene, which is derived from petroleum. In this process, ethylene is the polymer, the chemical building block of polyester. The other ingredient is a monomer used in this process. This monomer is prepared by reacting purified terphthalic acid with methanol to produce the exact chemical structure of the monomer, which is dimethyl terephthalate. The chemical process that produces the finished polyester is called polymerization. Polymerization. Polyethylene terephthalate is a condensation polymer and is industrially produced by either terphthalic acid or dimethyl terephthalate with ethylene glycol. To form polyester, dimethyl terephthalate is first reacted with ethylene glycol in the presence of a catalyst at a temperature of 302 to 410 degree Fahrenheit or 150 to 210 degrees centigrade. The resulting alcohol is combined with terphthalic acid and raised to a temperature of 472 degree Fahrenheit, that is 280 degree centigrade. Newly formed polyester is clear and molten. It is extruded through a slot to form long ribbons. Synthesis of linear polyester chain. A representative linear polyester PET is polymerized by one of following two ways: ester interchange or direct esterification. Ester interchange. This is a trans-esterification reaction in which one ester is transformed into another. Monomers are diethyl terephthalate and ethylene glycol. The other way of preparing PET is direct esterification. Direct esterification of carboxylic acid with alcohol is one of the most fundamental reactions in organic chemistry and widely used one-step atom-efficient method for ester synthesis. In this scheme, monomers are terphthalic acid and ethylene glycol. There is an option to prepare branched and cross-linked polyesters. If glycerol is allowed to react with a diacid or its anhydride, each glycerol will generate one branch point. As you can see, the glycerol is trifunctional molecule. Two of the hydroxys will react with carboxylic acid and the leftover will start the branching point. Such molecule can grow to very high molecular weight if internal coupling occurs. Internal coupling is reaction of a hydroxyl group and an acid functionality from branches of same or different molecules. In that case, polymer will become cross-linked. Rigidly cross-linked polymers are totally unaffected by solvents. Polyester fiber manufacturing scheme is shown in slide. Manufacturing process of polyester fiber includes following main steps: polymerization, melt spinning, drying, annealing and cutting. Polymerization. Purified terphthalic acid, which is a white powder, is fed by a screw conveyor into hot monoethylene glycol to dissolve it. Then catalysts and titanium oxide are added. After high temperature esterification and polymerization in almost total vacuum, monomer gets polymerized into final product PET. This viscous polymer is extruded into fibers after drying, cut into small pieces, chips. Melt spinning. The chips from storage are heated into melting chamber, which turns into thick viscous liquid. This liquid is then pumped to melt spinning machines, where polymer is pumped by a meter which discharges an accurate quantity of polymer per revolution. Spin rate, either circular or rectangular with specific number of holes to produce final denier. Final denier is actually the fiber density. Polymer comes out of each hole of spinneret and is instantly solidified by the flow of cool dry air. This process is called quenching. The filaments from each spinneret are collected together to form a small ribbon passed over a wheel which rotates in a bath, and this ribbon is then mixed with ribbons coming from other spinning positions. This combined ribbon is called tow and is coiled in canes. This material is undrawn tow and has no textile properties. Then comes drying, annealing and cutting. At next machine, the draw machine, undrawn tows from several canes are collected in the form of a sheet and passed through a trough of hot water to raise the temperature of polymer to 70 degrees centigrade, which is glass transition temperature of polyester, so that the polymer can be drawn. After the drying is complete, each filament has the required denier and has all its submicroscopic chains aligned parallel to the fiber axis, thereby improving the crystallinity of fiber structure and imparting certain strength. Next step is annealing, to set filaments strength by pulling them on several steam heated cylinders at 180 to 220 degrees centigrade. Then the fiber is quenched in a hot water bath, then passed through a steam chest to heat up to 100 degrees centigrade to facilitate crimping process. Textile finish is applied either before crimping or after crimping. The tow is then dried with hot air and then passed to cutter for cutting in desired length. These cut toe pieces are then wound on reel and is transported to a warehouse where it is matured for a minimum of 8 to 10 days before dispatching to spinning mill.